Hello, my name is Alexis Campbell, and today I will be doing problem 45 from chapter 15. It is about relating the equilibrium constant to the equilibrium concentrations / partial pressures. Today we will be focusing on concentrations. Problem 45 is as follows. It first gives us an equation involving all gaseous species, and then gives us the volume of the entire container and the individual gram values of the components. However, the gram value of the product is given at the equilibrium value. The goal of this problem is to find what the equilibrium constant is. The given values that we will use was the total volume, which was 3.67 liters, and the individual masses. For hydrogen, it was 0.763 grams, and for iodine, it was 96.9 grams. For HI, we have to remember that the value was given at the equilibrium value, and that was 90.4 grams. We are finding Kc. Problem 45 can be divided into 5 different steps. We will first use stoichiometry to convert the given gram values into molarity values, which will give us the individual concentrations of each component. We will then fill out a rice table and find X. We will then use X to solve for the equilibrium concentrations, which we will then plug into a Kc equation and solve for Kc. The first step involves stoichiometry. We converted each mass value for each component within the reaction into molarity values. We started with mass values and then multiplied by molar mass, which is highlighted in green. We then divided each molar value by the total volume to get molarity. It is important to remember that the concentration of HI that we found is at equilibrium, unlike the concentration of H2 and I2, which are the initial concentrations. Step 2 involved filling out a rice table. We started with our reaction, and then the next column is all of our initial values which were given. C then stands for change. We use the variable x and base the change off the stoichiometry values within the reaction. The equilibrium row, or E, is a combination of our initial concentrations and our change equations. It is important to remember that the equilibrium concentration for HI was given. This is written in red. Step 3 is a different way to find X than we learned in class. Since the change in HI is 2x, and the reaction originally had no HI, you can set 2x to equal 0.193, the given equilibrium concentration of HI. To solve for our equilibrium concentrations of the reactants, we must go back to our rice table. We then plug in X in our equilibrium equations that were derived from adding together our initial values to our change in variables. Our equilibrium concentration for hydrogen is 0.0065. Our equilibrium concentration for iodine is 0.0075. Our final step is to find Kc. We first must write an equation based on our reaction. Kc is equal to product concentrations over reactant concentrations. The concentration for HI is squared since the reaction yields 2HI when the equation is balanced. You then plug in all of the concentrations that we found using the rice table for H2 and I2 and the given value for the concentration of HI. All of these values must be at the equilibrium concentration. This will give you Kc equals 764.